The topic of presentation is application areas of geographic information system in construction. These application areas have been divided into 6 categories depending upon different stages of construction. So first we will start with the feasibility stage, then design stage, planning stage, construction stage, operation and maintenance stage, then demolition stage. The reported application areas of GIS in feasibility stage are selection of sustainable site, modeling of regulatory requirements, extending services to site, surface and subsurface conditions. So first reported area, that is the selection of a suitable or sustainable site. Actually, there are so many factors which govern in selection of a site. So GIS provide these multiple decision-making capabilities, and with the help of that, we can take suitable parameters into consideration, and we are in a position to identify most appropriate or sustainable site that fulfill the constraints or satisfy different criteria. GIS has been used to identify sites for different types of construction projects, just like real estate projects, shopping malls, and many others. The second research area in the feasibility stage, that is the preliminary survey and modeling of regulatory requirements. We have discussed earlier also that GIS helps in modeling topography and facilities or utilities in its surrounding, or in other way we can say that it helps in modeling surroundings. So once we have that virtual surrounding with us, with the help of that we can do preliminary site visits. We can measure distance on inclined surface. We can find corresponding projected distance, and other thing that we can model in GIS, so that is the that rules and regulations. There are the different bylaws which changes from one place to other place. So GIS sometime or in some literatures are used to model those government rules and regulations. Then after that, a construction requires some basic facilities. So this is the third area in the feasibility stage, that the GIS helps in planning of extending utilities or services to a particular site. So these utilities or services are just like a water supply, that just to plan or connect the existing site with the available water supply network or sewer network, or just to bring that electrical connection to a particular site, gas connection, or just to construct access roads. So there are the different researches which have been reported in this area, just like to use of GIS and expert system to plan the heavy vehicles which are carrying consignments from the different places, or just like identification of tunnel route without damaging the underground facilities or utilities, that those may be the electrical line or existing this utility lines, just like water supply or gas lines. The fourth area that has been reported is the surface and subsurface conditions of the site. So whenever there is let's say tunnel construction is there, then what are the surface and subsurface conditions? Those play a major role. So GIS helps in modeling those surface and subsurface conditions. Actually, those conditions also decide that what construction method is to be used. So there are few studies have been reported in which they have use that borehole data, and that borehole data is used to generate surface profile also. And sometimes depending upon that profile, we are in a position to decide that what construction method is to be used, which type of equipment is to be used to carry out that construction. There are some other areas which have been reported in which GIS along with this building information modeling software has been used in the feasibility stage, that or those areas are data integration, preliminary cost estimation, planning sustainable built environment, subsurface utility visualization, view coverage, and shadow analysis. So second stage, that is the design stage, very limited application of GIS has been reported in this design stage, that include public participation in planning and design. Actually, whenever we take some decisions while designing a particular facility or utility, so that the public participation in decision making is ensured by the use of GIS. So the GIS-based visualization technique help in enhancing this public participation in planning and design. And other thing that GIS help in modeling topography, develop very good simulation. So those also help in this planning and design of some complex constructions, such as like gravity dam or some civil engineering structure in hills. There are the few applications in which GIS along with BIM has been used in the design stage, which include design for low energy consumption or development of specific function which may be helpful in planning and design. Then the third stage is planning stage. The reported application areas in the planning stage are construction cost estimation, screening of contractors, scheduling and 4D modeling, location-based planning and scheduling, resolving space conflicts, planning for construction safety. So first, construction cost and conceptual cost estimates. There are the few studies which have been reported in which the GIS has been used for quantity takeoffs. What is done, those layers which have been prepared in the AutoCAD, those are imported into the GIS software, and those layers are used for quantity takeoffs. Once we have quantity takeoff in GIS, so then if we maintain a database of unit cost, then we are in a position to identify, to calculate construction cost or cost estimate for a particular location. Then second application that has been reported, that is screening out of contractors. Actually, every contractor is competent to do work better in a particular conditions or on a particular geographical location. So this GIS, this research has been reported in which use of GIS has been explored by considering the spatial aspect to screen out contractors in order to determine their competency to complete the construction work on a specified location. This is a third application area of GIS, which is widely accepted, that is the construction scheduling and 4D modeling. So GIS has been explored for scheduling. Even let's say that schedule we prepare in Primavera or Microsoft project, that the schedule can also be imported into GIS, and that schedule can be linked with the 3D components. And those 3D components may be developed in GIS, or they can also be imported into GIS from some modeling software. And those 3D models are linked with the corresponding activity in the schedule to develop 4D execution sequence. And there are a lot of applications of this 4D modeling in the construction. Other area, that is the location-based planning and scheduling. So GIS helps in location-based planning and scheduling, where simultaneous activities are there and resource continuity is required. So mainly here that repetitive scheduling is done. Then other area is resolving time-space conflicts. Actually, schedule is just a timetable of doing work. So at different times, different activities take place, and their demand of space is different with time. So it is a dynamic problem actually. So GIS is used for detection and resolution of time-space conflicts in construction. And let's see if conflicts are identified, then accordingly schedule is modified. Then planning for safety and low disturbance. So if we have, let's say, 4D modeling in GIS, so we know that what is to be constructed when. If that, let's say that 4D model has been prepared in GIS, then it gives you the idea about what is to be constructed when and where. So where component comes from GIS. So GIS help in this developing safe execution construction sequence and planning for low disturbance during construction. There are the few areas in which GIS along with VIM has been used. Those are construction planning, visualization of construction process, indoor geovisual analysis. Then fourth stage, that is the construction stage. The application areas reported in the construction stage are planning human workforce, material trading, material layout planning for temporary facilities, tracking site dynamics, and construction progress control. So first, planning for human workforce. Actually, workforce do not keep themselves at rest. So if we have database related to the human workforce in GIS, so we can plan that if let's say there is a shortage of worker, we can plan that from which place worker can be brought to a particular site. So in this way, this GIS helps in planning of human workforce. So the capability of GIS to integrate different data sets together to have bigger picture of what is happening geographically around the country may create a solid platform for future planning of construction industry. Then material trading. Actually, whenever there is some purchasing, either that supplier or buyer establish direct link, or that link is established through agent, or third possibility is that through internet, that link between this buyer and supplier is established link. So when it is through that link is through web, so in that GIS plays a major role, because material can be ordered online, but that now handling of that material or transportation of that material is offline. So now transformation of material to particular site in that topography play a major role. So here internet-based GIS provide an ideal solution to manage the cost of transportation of construction materials. Then material layout planning. When material estimate is linked with the schedule, then it generates dynamic material requirement. Now GIS store the site information. So we know that at what time which material is to be stored or how much materials are to be stored. So once we have dynamic material requirement with us, GIS helps in identification of suitable locations on site. Then then we are in a position to store material at site properly. Then layout of temporary facilities. Again, that site layout system for construction of temporary facilities at site is governed by so many factors. So in which GIS is helpful. So that this GIS-based system integrates information required to find out suitable locations for temporary facilities, depending upon the requirement when that facility has to be located and when that particular facility has to be dismantled. Then tracking site dynamics. So GIS, along with some other technologies, just like GPS, helps in getting real-time information or real-time movement of different resources. So which are quite useful, both locating the movement of this resource or locating resources and the real-time movement also. Then construction progress control. So actually we have the construction plan, and we can just somehow record the construction progress, then in which GIS is helpful. Then by comparing the planned progress with the actual progress which we are getting at site, suitable control measures may be decided. The other application areas which GIS along with VIM has, those are construction supply chain management, optimizing location of equipment on a site, load disturbance construction, ensuring safety during construction, knowledge process of the building, and documentation of construction project. Then just few applications have been reported for this operation and maintenance stage. Those are maintenance on distributed sites, decision support systems, and automated drainage analysis. So this is the study that in which this infrastructure maintenance programs were going on different locations. So in which they have reported that GIS use has been found quite useful. Then real-time disaster decision support system. So GIS is used for disaster decision support system, focusing on real-time observation. GIS helps in selection of particular machinery or equipment required under specific conditions or on a particular location where disaster has been taken place. Then automated drainage analysis. So let us suppose somehow site get flooded. In that case, the GIS helps in maintaining the information about or special information about surrounding. So quickly we can plan that how to drain that site to again start construction there. Other applications which have been reported along with VIM in this operation and maintenance stage are integrated pre-retrofitting, reuse of existing facilities, flood damage assessment, facilities asset management, monitoring historical buildings, and web-based GIS management. At last, in the demolition stage, the application reported that is the distribution of construction equipment. So This study developed a GIS-based framework to support equipment distribution for civil engineering, disaster response operations. So other applications of GIS along with the BIM, those have been reported in this demolition stage are building, construction waste management, and damage assessment. So this is the reference for further detail. Another reference for more detail. If I summarize the GIS application in different stages. So first, GIS use has been reported widely for selection of site for a particular facility. Once site is selected, we can model its surface. Now here, along with the surface, we can do survey and we can map existing facilities and utilities that both are combined to have the model of surrounding, which is once we have virtual surrounding with us, then that virtual model of surrounding is quite helpful in the feasibility stage. Now we develop schedule. It may be in GIS or it may be in some other software, because that can also be imported into GIS. Then we can do 4D modeling in GIS. The 4D modeling means we can link 3D model with the schedule to develop 4D modeling. Now, whatever that 4D modeling or that sequence is, that is seen along with its surrounding. We can design also in some software. So, but at this stage, we have that for execution sequence along with its surrounding. Then we can model some site constraints which every site offer. Now once that virtual part is over, then that construction starts. So during construction, that GIS can be used for site layout planning for material layout, progress monitoring, real time information clash detection, and ensuring safety. Now, once construction is over, then GIS use has also been explored for operation and maintenance planning. Then finally, in the demolition planning. At last, in the summary, if we see if there are the balanced applications, so that means that application of BIM, application of GIS, and application of integration of BIM are same. Then we have this type of representation, but they are not same. You'll find lot of application of BIM in this building life cycle, very less applications of this GIS, and a few applications have also been reported in which BIM and GIS have been used together. So this was all about the application areas of GIS in construction. So thank you very much.